We will solve one problem based on free expansion of a gas enclosed in a piston cylinder assembly, and will evaluate the work done. Okay, so question is, one kilogram mole of an ideal gas at a pressure of 700 into 10 power 4 Newton per meter square and at 300 Kelvin is confined in a piston cylinder assembly as shown here. Okay, so this is a gas confined in a piston cylinder assembly, piston plus piston rod, it's held up in a particular position by the latches. Piston is held in a position by latches. The weight of the piston plus this piston rod, together is 20 kilogram. That is weight of the piston plus piston rod is equal to 20 kilogram. And a weight is kept on the top of the piston rod, which is of 45 kilogram. A weight is placed on the top of the piston rod and is of 45 kilogram. The space behind the piston, it is evacuated, which means it is devoid of air. No air in this space that is behind this piston. So it is evacuated, no air, or it is devoid of air. And the cylinder is immersed in a constant temperature bath to maintain a temperature at 300 Kelvin. Okay. So the problem is, the 1 kilogram mole of an ideal gas at an initial pressure of 700 into 10 power 4 kilogram per Newton per meter square, and at 300 Kelvin it is enclosed in a piston cylinder assembly. Gas is confined in this piston cylinder assembly, and the pressure is maintained by the piston plus piston rod and the weight that is placed over the top of the piston. Now the latches holding these two positions are removed and the piston is allowed to expand rapidly. So it is allowed to expand rapidly. Once the latches are removed, the piston is allowed to expand rapidly through a distance of 40 centimeter. This is of 40 centimeter. It is raised. So it is 40 centimeter. The piston will move to a height of 40 centimeter once the latches are removed. And it is once again held by the latches at the new position. Okay. If the cross-sectional area of the cylinder is 1 centimeter square, area of the cylinder is 1 centimeter square, you need to evaluate 1 centimeter square, evaluate work done if gas alone is considered as the system, if gas alone is considered as the system. So the initial gas is at a pressure 700 into 10 power 4 Newton per meter square, and once the latches are removed, the gas freely expands and it is raised through a height 40 centimeter. We need to know how much work is done when the gas alone is considered as the system. Gas confined in the cylinder, this is the system boundary, and once the gas alone is confined in the system, assuming this piston rod plus weight are contributing for the external resisting pressure. So work during the expansion of the gas, the work is done against the resisting pressure contributed by the piston rod weight, that is of 20 kilogram, plus the additional weight, that is 45 kilogram, that is placed on the top of the piston. So once it expands from an initial pressure P, pressure reduces from an initial pressure P of 700 into 10 power 4 Newton per meter square, there will be a reduction in the pressure. So work done against a resisting pressure to achieve a new volume V is what you need to calculate. So what is the resisting pressure? The resisting pressure, because of resisting pressure due to the weight, the total weight of piston plus piston rod, that is 20 plus due to 45 kilograms. Since it is placed on the piston, it is acting it as a resisting pressure for the expansion of the piston, expansion of the gas. So what's the total weight? So it is 65 kilogram. Okay, how to calculate the resisting pressure P? P is equal to force per unit area. So what is force? Force is due to this weight 65 kilograms. So F is equal to mg divided by A. Okay, so calculate P. So P is equal to M is 65 kilogram, G is acceleration due to gravity 9.8 meter per second square. What is the cross-sectional area? 1 centimeter square. So 1 centimeter square cross-sectional area is in 1 centimeter square. You can convert into meter square, that is 1 into 10 power minus 2. 1 into 10 power minus 2 the whole square. Centimeters converted into meter, that is 10 power minus 2 whole square. So that much meter square. So the answer P is equal to 637 multiplied by 10 power 4 Newton per meter square. Kilogram meter per second square is Newton per meter square. So what is work done? We need to evaluate the work done. So work done is equal to, work done, the PdV work, P delta V. Okay, how to express delta V in terms of A and height, A and del Z. So P is 637 into 10 power 4 Newton per meter square. You can see that the pressure has reduced from 700 into 10 power 4 Newton per, initial pressure was 700 into 10 power 4 Newton per meter square, and during the expansion of the gas, pressure reduced to 637 into 10 power 4 Newton per meter square. So work done can be evaluated as P del V multiplied by P multiplied by, what is del V? Area into height, A into H. What is area? So 637 into 10 power 4 Newton per meter square, multiplied by area is 1 centimeter square. I'll convert into meter. 1 centimeter square, 1 is 10 power minus 2 the whole square. So you will get in meter square, multiplied by h. The piston has raised to a height of 40 centimeters. So 40 multiplied by 40 into 10 power minus 2 meters. Okay. So what's the answer? Work done is equal to 254.8 Newton. Meter square cancel, Newton meter or joule. Work done as 254.8 Newton meter or joule. Or you can calculate work done as work is equal to displacement work. F is equal to work done is equal to work is equal to F into dz. What is F? F is due to the resisting F. F is due to the mass, that is because since we consider the gas confined as the system, the external thing to that gas or the objects that are contributing to the resisting pressure, or the reason for the resisting pressure is because of the piston plus piston rod plus the weight. So F you can calculate as mg, that is due to piston rod plus the weight, multiplied by 9.8 meter per second square, multiplied by the change, the piston has rise, the expansion, work done or the energy expended in the form of work once the object travels through a distance. Once a piston moves through a distance 40 centimeter, that is 40 into 10 power minus 2 meters. So what is the answer? It will be, should be 254.8 Newton meters. So you should get the same answer if you calculate by estimating pressure, resisting pressure, and using a P del V as work done as P del V, or work is equal to F dz, the displacement work. Now the second question is, so the gas initial, in the first case gas alone is considered as a system. Now I am considering another boundary for the system, that is gas plus piston rod. Piston plus piston rod can be considered as the system. Consider gas plus piston rod as the system. So here what causes this external pressure? The external pressure is due to W, that is 45 kilogram. Piston plus piston rod contributes to 20 kilogram. Piston plus piston rod, it contributes to 20 kilogram. Whereas, so now I'm considering, instead of this gas, I'm considering gas plus the piston. So entire boundary of the piston plus this piston rod is considered to be as my system. So gas, piston boundary plus piston rod is considered as the gas piston boundary plus piston rod. It is considered as the system. So only the external, there is no air behind the piston. So there is no resisting pressure due to atmospheric air. So only the weight is, only the reason for this resisting pressure is this weight, that is 45 kilogram. So you calculate the resisting pressure, you calculate the resisting pressure due to this weight, pressure due to W, that is 45 kilograms. So that resisting pressure P is equal to, as we have already discussed, P is equal to F by A, which is equal to mg by A, whereas M is 45 kilogram, M is 45 kilogram, G is 9.8 meter per second square, divided by A is 1 centimeter square, 1 into 10 power minus 2 the whole square. So what will be the pressure? What's the answer? Pressure. So pressure is equal to 441 Newton per centimeter square, which is 441 into 10 power 4 Newton per meter square. So you can calculate, you can see the pressure has reduced to 441 into 10 power 4 when the weight alone is the cause for the resisting pressure. Instead of 637, from 637 it has again reduced to 441 because only the 45 kilogram is there to exert a resisting pressure. So how to calculate work? Work done as P del V. P is 441 into 10 power 4 Newton per meter square multiplied by del V is area into height. Change in volume can be written as area into height. What is area? 1 into 10 power minus 2 whole square, that is 1 centimeter square, multiplied by height is 40 into 10 power minus 2 meters. So we will get the work done as 176.40 Newton meters or joules. So work done, once the weight has reduced to 45 kilogram, less amount of work is required for the expansion. Okay. Now the third case, gas plus piston rod plus the weight placed on the piston rod together is considered as the system. Okay, so the entire, in this case we have discussed the gas plus the piston, the gas plus the piston plus piston rod plus this weight together is considered to be as the system. So the system boundary is now expanded, it is moved to a new system. So the gas, piston rod, this weight is entirely considered to be as the system. So is there any existing external pressure? So the resisting pressure, there is no resisting pressure. So resisting pressure is 0. So in the third case, the resisting pressure is 0. Pressure is equal to 0. So why resisting pressure is 0? Because behind the piston it is evacuated. Okay, there is no air, no atmospheric pressure. If air is there, then you can assume it as atmospheric pressure exerting is the external pressure. So resisting pressure now is 0 because since it is devoid of air, and at the same time we consider the entire piston cylinder assembly plus the additional weight that is kept on the top of the system as the system. So the resisting pressure now is 0. So what is the work done? Work done is equal to P del V. So what is the resisting pressure? It is 0. So work done is equal to 0. No work done. So no work done when you consider the entire system, entire piston cylinder assembly with the additional weight as the system.